Now, in this question, we are given that Jill has applied for a job with each of the two different companies. We have to find the probability that she will get job offers from both the companies. So, let the companies be A and B. We have to find out the probability that she will get a job offer from both A and B together. Now, before moving on to step 2 and analyzing the statements, let's understand what are the possible cases. So the case 1 can be when she gets a job offer from A and a job offer from B. Case 2 can be when she gets a job offer from A but not from B. And similarly, case 3 would be when she does not get a job offer from A but gets an offer from B. And obviously, the last case possible here is that she does not get a job offer from any of the two companies. Now, the first case can be written as the probability of getting a job offer from both the companies. The case 2 and case 3 can be summed up as the probability of getting a job offer from exactly one company. And the last case can be written as the probability of getting a job offer from none of the companies. Now, we know that the total probability is equal to 1. So, from the cases, we can write that probability that she gets a job offer from both the companies plus the probability that she gets a job offer from exactly one of the companies plus the probability that she gets a job offer from none of the companies, this equals to 1. Now, this kind of pre-analysis is necessary so that in the statements, when you write down the given information from the statements, you do not end up making mistakes. So, take out some time and do such pre-analysis in the step 1 itself. This will save you time in the step 2. So, keeping these in mind, we move on to step 2 and analyze the statement 1. So, the statement 1 tells us that the probability that she will get a job offer from neither of the company is 0.3. We know that the probability of none is equal to 0.3. So, using the equation that we had formed in step 1, when we substitute the value, we get P of probability of getting a job offer from both the companies plus probability of getting a job offer from exactly one of the companies plus 0.3 equals 1. Now, this is a linear equation with two unknown variables. So, it is not possible to find the value of the probability of that she will get offers from both the companies. Hence, we conclude that statement 1 is not sufficient. And from the given options, we eliminate A and D. We now check the sufficiency of statement 2. In statement 2, we have that the probability that she will get a job offer from exactly one of the two companies is 0.5. That means P of exactly one of the two companies is 0.5. Again, if we plug in the values, we have an equation which is probability of getting a job offer from both the companies plus 0.5 plus probability that she gets an offer from none of the companies equals 1. Now, this is also a linear equation in which two variables are unknown. So, we cannot find the value of the probability that is required. Hence, we conclude that statement 2 is also not sufficient. And we move on to the last step, which is the step 3, and analyze both the statements together. Now, let's write down the information that we get from the statement 1 first. Statement 1 tells that P of none is 0.3 and statement 2 tells us that P of exactly one of Jill getting exactly one offer is 0.5. Now, if we plug in these values in the equation, we get probability that she get an offer from both the companies plus 0.5 plus 0.3 equals 1. Now, it is possible to solve this equation and find the probability that she gets an offer from both the companies, and hence both the statements together are sufficient. So the correct answer is option C.